Alright, so we're going to look at some important plots. The reason why these plots are important is their methods to solve for Km and for Vmax. Your first plot that we're going to look at is V naught versus S. It's just your basic Michaelis-Menten plot. Couple things to notice. The velocity levels off asymptotically. That's going to be Vmax. Second point is when Vmax, or when V equals Vmax over 2, make sure you understand that the concentration of S is equal to Km. Second plot, Lineweaver-Burke. We spent a lot of time on this in class. We have Y equals mx plus b. So we turn this thing into a linear plot by taking the double reciprocals of both points. The slope is going to be equal to Km over Vmax. Your y-intercept is going to be 1 over Vmax. And then your x-intercept is going to be negative 1 over Km. Okay. Last plot, we didn't really talk too much about this in class, the Eadie-Hofstee plot, but what they did is they took the Michaelis-Menten equation and they rearranged it again so that we get a nice linear plot, y equals mx plus b. Make sure you understand what the intercepts and the slope are. Slope is going to be negative Km. Y-intercept is going to be Vmax. And then your x-intercept is going to be Vmax over Km. Okay, so Vmax over Km. All right, so these plots, they're very important because they're ways to solve for Km and Vmax. Particularly for the linear plots, make sure you know the slopes and the intercepts. For the plot on the left, to make sure you understand what Vmax is and where Vmax over 2 is. And that at Vmax over 2, your concentration of substrates equals Km.